Hello everyone, my name is Andrew Ulrich Tindangen from Information System Class B. So now I'm gonna explain about my assignment paper on graph theory, and the title is Minimum Spanning Tree. So what is minimum spanning tree? Minimum spanning tree, or MST, or in Indonesia it says pohon rentang minimum, is one of the important on the graph. To find a graph that theory is one of the important concept in graph theory, which focuses on finding a graph that has the minimum weight of all possible graph that can be formed from a original graph. This concept is applied in a variety of applications, such as in design for computer networks, cost optimization, and data structure analysis. So MST has several algorithms that can be used to solve problems, such as the Kruskal algorithm, which works by sorting all the edges in the original graph based on their weight. Then the edges are connected with the one with the smallest weight until all the vertices in the original graph are connected. And next, the prim algorithm works by selecting the initial node in the original graph, then connecting the edge that have the smallest weight from the initial node to other nodes until all the nodes in the original graph are connected. Graph in the application of MST using the two algorithm described earlier, namely Prim and Kruskal, are also explained in detail in the reference book entitled Introduction to Algorithms 2009 of Corman, Laserson, Rivers, and Stein. So the application in real life, example on the wired networks. In computer network design, MST is used to find routes that have minimum cost to connect multiple nodes in the network. In this example, MST helps in saving cost and increasing efficiency in network usage. On the pipe networks, in design pipeline networks for the water or oil distribution, MST can be used to find the most economical pipe routes. On the transportation networks example, in planning transportation, networks such as roads or railways, MST can be used to find the most efficient routes with minimal construction costs. On the clustering, MST can be also used in clustering algorithms to group the database on similarity or closeness between data. So, Kruskal and Prim's algorithms have the same time complexity, namely O. On the Indonesian, say O dalam kurung E mutlak log V mutlak nilai V mutlak tutup kurung, where O is a big O notation used in algorithm complexity analysis. E mutlak, number of sites, and the V mutlak or V mutlak itu number of nodes. The formula notation O dalam kurung E mutlak log V mutlak shows that the worst case time complexity of the Kruskal and Prim algorithm E log V or E mutlak log V mutlak. However, in the implementation, Prim's algorithm is often more efficient in certain cases. In this big This because prim algorithms does not require explicit ordering of the edge as does Kruskal algorithm. So for the application example, suppose a telecommunication company wants to build a telephone cable network connecting on 5 cities A, B, C, D, E. Each CD is represented by a node, where the cable or weight on each edge represent the cost of building a cable between the two cities as follows. We can see on the presentation, A to B is have weight 5, E to C 3, B to C is 6, B to D is that weight is 4, C to D is 7, C to E is 8, and weight of D to E is 9. So for the solution, we can find, in this case, we must use the MST or minimum spanning tree for the optimal solution and use only one of these algorithms, namely the Kruskal algorithm. And from this data, there are 5 cities with 7 relations that are connected to each other and have their respective weight as in the graph description. Because it uses the Kruskal algorithm, the first thing we do is sort the site data and their weight or value from smallest to large first. On this presentation, we have the picture edge and value on the smallest to large, and this one is the graph. So next we will sort the edge that have the smallest weight to get a minimum spanning tree, provided that the edge that will be selected later do not from a series connected to the other nodes, and this step will be repeated until n-1. So like this on the presentation. And from the result we have obtained, we can see that there are 4 edges with the red lines that are not connected to each other, forming a circuit. So that we get a minimum spanning tree from the graph with a minimum weight and the total number of weight. So we have 3, 4, 5, and 8. So we can conclude that 3 plus 4 plus 5 and plus 8 is 20. Like on the graph, we can see like that. And the minimum spanning tree of the graph, it's like that. So for the conclusion, minimum spanning tree or MST is an important concept in the graph theory, which aims to find a subtree with a minimum total weight that connects all vertices in a weight graph. The two main algorithms from finding MST are Kruskal, which works by working edge from the smallest weight and selecting edge to do not from cycles, and Prim, which starts from the initial node and iteratively adds edge with the smallest weight that connected with the nodes, connected new nodes, but have a time complexity of O E mutlak log V mutlak, but Prim is more efficiently because it doesn't require explicit edge ordering. MST is widely applied in various fields such as cable networks, pipes, transportation, and data clustering, like the example, with the aim of optimization and cost of resource efficiency. So thank you for watching and see you.